Okay, today's lesson is going to be lesson 9.3. We're going to be talking about properties of rotations. So let me get started. Okay, so our standard is going to be I can define a rotation, I can understand properties of rotations, and I can graph rotations. So far we've learned about translations, we've learned about reflections, and now it's rotations. We're covering the standards G1 and G3 and describing the effects of dilations, translations, rotations, and reflections on two-dimensional figures using the coordinate plane. And then G1 was verify experimentally the properties of rotations, reflections, and translations. And then so rotations is today. I'm going to minimize myself and get going. Okay, let's explore rotations. A transformation is a function that describes a change of a figure in position, size, shape, or orientation. That should be reviewed for you. The input is the pre-image, the output is the image. And at the bottom there, a rotation is a transformation in orientation. It's a turn, correct? So a rotation is a transformation that turns a figure around a given point. The point about which the figure is rotated is called the center of rotation. The image will maintain its same size and it will maintain its same shape as the pre-image. So here's an example. You can see the center of rotation where the arrow is there. That is right here. And then this is being rotated this direction. So here's A prime, B prime, and then 0. Okay, measuring degrees of rotation. So if I give you a circle like this, I can divide my circle into quadrants, just like the coordinate graphing is divided into 4 quadrants. So I can start here, and that would be considered 0 degrees. Now, as I go around the circle to the top, right here, I have gone 90 degrees. And you may be familiar with that concept of a 90-degree angle. When you see the little square in the corner, that's an exact 90-degree angle. The side here and the side here are called perpendicular to each other. It forms an exact 90-degree angle. If I keep going around the circle, I now get to this point. Every quarter of the circle is another 90 degrees. So if I'm adding 90 degrees to the top to get to the new point, what is that number going to be? 90 plus 90, 180 degrees. Then if I keep going around the circle to this point, that's another 90 degrees. So you would add 180 plus 90, 270 degrees. And then if I go all the way back to where I started, adding 90 degrees more, I get 360 degrees. So a full circle is 360 degrees. So we're going to be talking about rotations that will rotate 90 degrees, 180 degrees, 270 degrees, okay? They can rotate any one of those 3 areas. Now, in real life, when you get into high school, they can rotate anywhere in between. So you could have a shape rotating maybe in between 0 and 90, or in between 90 and 180. Anywhere in between here, it could rotate. So we're just going to be talking about the basics with our rotations. Okay, I'm going to demonstrate something under the document camera. So hold your horses. I'll be right with you. Okay, we are going to take this triangle, and this is page 291 in your book as well. We are going to take the triangle you see here, the pre-image, and we are going to rotate it counterclockwise 90 degrees at the origin. So here's the origin. Counterclockwise, you got to think backwards about the way that a face clock would go. So this is the backwards way. A clock doesn't go this way, does it? It goes the other way. So counterclockwise is backwards this way. So that means we're going to take this shape and we're going to rotate it this way. How much are we going to rotate it? 90 degrees, so 1/4 of a turn, 1/4 of that quadrant of a circle. We're going to go like that with it. So if we do that, we will end up with, if you notice, if you can picture it in your mind, we're going to end up with this side here that's now on the x-axis is now going to be on the y-axis when we turn it. So we are going to put our new points. This is going to stay A prime, isn't it? I mean, it's going to stay in the same spot because we're rotating it about the origin. This will become B prime, and this will become C prime. And then we connect our dots. So see how that's a rotation? A 90-degree rotation to the left, counterclockwise. Okay, now what if, see what it's telling us in our book here. I want to rotate it again. We can rotate it again if we want to. I'm just looking to see what it's telling us. Rotate triangle ABC 90 degrees clockwise about the origin. So this was counterclockwise. Now let's take this one, the original, and move it clockwise. So clockwise is going to go, so this is counterclockwise, and this is going to be clockwise. So let's do it again. Now where are we going to end up with this time? This base is on the x-axis when we rotate it clockwise. This base is going to be on the y-axis, right? Same deal. So the A point is going to stay in its same spot, but now it'll be called A double prime. This is now going to be B double prime. And C is going to be right over my words here, right there. That will be C double prime. And if I connect my dots, I have now rotated my triangle 90 degrees clockwise. Notice how the size stayed the same. Notice how the shape stayed the same. What changed was the orientation. Okay, let's go on to the properties of rotation. It's very similar to what we talked about in the other two videos, properties of translations and properties of reflections. So rotations will maintain the same length of their corresponding sides. Rotations will maintain the same measures of their corresponding angles. The sides that were parallel in the pre-image will remain parallel in the image. The rotations will preserve the size and shape of a figure, but its orientation changes by turning the original figure. A rotation produces a figure that is congruent to the original figure. Again, congruent means that figures that have the same size and shape. So now I'm going to demonstrate for you again. Okay, this time we have a trapezoid, and this is page 292 in your book. The trapezoid is called TRAP, trap, and we want to rotate it 180 degrees counterclockwise. Now just be aware, it doesn't matter if you rotate something 180 degrees counterclockwise or clockwise, you're still going to end up in the same spot, right? So I thought it might be good if I just took this and I cut it out so you could visually see it. So here's our shape, and it wants us to rotate it about the origin. So I have to move it up to and go by the origin, and I'm going to rotate it 180 degrees. That's half a circle. So this is going to end up here, but I've got to be 2 spots away. So that's where it's going to end up. And if you notice where all the letters have changed now, and I can rewrite them here, you can kind of put the points in there so you can see them. And I'll put the points right side up here. So this is P prime now. This is T prime. This is R prime. And this is A prime. So let me show that to you again. We started here. We want to rotate it 180 degrees. So that's going to be a half away like this. But we have to do it about the origin. So there's the origin. I moved it up. I rotated it about the origin, and then I have to go 2 diagonal spots, just like the R is from there. So that is my, and I will connect my dots. Okay, there it is. That is a rotation of 180 degrees counterclockwise. Notice how each side, TP and TP have the same length still. TR and TR have the same length. AP and AP have the same length. So all of the side lengths have been maintained. All of the angles are still the same. Angle A is still the same as it was over here. They have also kept their shape. So the angles and the shape are the same. The sides that were parallel before are also parallel here, right? They're all still parallel. The only thing that's changed is the orientation. It's now upside down. It's been rotated 180 degrees. Now let's see what would happen if we were to rotate it 180 degrees clockwise. Let's put it back here, and we're gonna go, so we gotta first go about the origin, and then we're gonna turn it 180 degrees. Notice how we end up in the same spot, whether we go counterclockwise, like this, rotate it, move up 2, or if we go clockwise, start at the origin, this is clockwise now, and go up 2. So we don't really have to specify when we're going 180 degrees which direction we're going, because either way we end up in the same spot. So keep that in mind as we get into some of the harder stuff. Okay, so when we're graphing rotations, which we just saw a little bit, we are going to rotate the figure in the coordinate plane. We're going to end up thinking about how we would rotate each of the vertices, each of the A, B, C, D points. Then we connect the vertices, or we connect the dots. And remember, a vertex is one singular version of a corner, where a vertices is the plural of all the corners. Okay, you get a turn to try some problems, and I'll see you back in a moment. Okay, welcome back. Okay, we have some things we have to memorize. So I am going to show this to you, and then I'm also going to show you a graphing example as well. So if a figure rotates 180 degrees, remember that's a half a turn, then the X and Y coordinates will change signs. So here's how it would be looking. If it was X and Y originally, you're going to switch it around, and not switch it around. You're going to put a negative sign in front of X and in front of Y. However, if X and Y were negative to start with, then they're going to become positive. So if P was 3, 6, it would become negative 3, 6. That's for a 180 degree turn. If the figure rotates 90 degrees clockwise, that's a fourth of a turn. It's a fourth of a turn down, right? Clockwise would be down. Then the coordinates switch places, and the new Y becomes the opposite sign. Let's take a look. Here's 90 degrees clockwise. It was XY. They're going to switch places. Y is going to become the new X, and X is going to become the new Y, and the X is going to become the opposite of what it was. So if P was 6, 12, it would become 12, negative 6. If the figure rotates 90 degrees counterclockwise, that's a fourth of a turn up, right? Then the coordinates switch places and new x becomes the opposite sign. So with a clockwise turn of 90 degrees, new y becomes the opposite sign. With a counterclockwise 90 degrees, new x becomes the opposite sign. So here you have a 90 degrees clockwise. You're going to switch places. Y is going to become x and x is going to become y. And then the y value is going to become negative, or the opposite of what it was. So we have example of P equaling 2, 5 down here at the bottom. And it's going to be switch places, and then 5 is going to become the negative, and 2 is going to stay the positive, or whatever it was before. If you have a 270 degrees counterclockwise turn, that's 3/4 of a turn, then the coordinates will switch places and the new y coordinate takes the opposite sign. So x and y would become y and negative x. For example, P, if it's 4, 8, becomes 8, comma, negative 4. Note that rotating 270 degrees is the same as rotating the figure 90 degrees in the opposite direction. And then you only need to memorize the 90-degree rules. So if you can remember, 270 is a rotation that will land you in the same spot as 90 degrees, right? In the opposite direction. So if I'm going counterclockwise 270, that's the same as 90 degrees clockwise. So there's your point. A rotation of 270 counterclockwise is the same as a rotation of 90 clockwise. And the opposite, a rotation of 270 clockwise is the same as a rotation of 90 counterclockwise. Okay, hopefully I didn't totally confuse you on that. As you work with it, it gets a little easier. Okay, let me demonstrate for you under the document camera. I'm hoping you can see most of this. So we're going to rotate ABC, triangle ABC, after a rotation of 90 degrees clockwise at the origin, clockwise, that direction. So step 1, rotate the figure clockwise from the y-axis to the x-axis. Okay, we're rotating it this way, 90 degrees, 1/4 of a turn. So point B is 2 units left of the y-axis, right? So B prime is going to be 2 units above the x-axis. So it goes from switching to 2 units to the left of the y to 2 units above the x. So it's going to end up, where are we going to put this? Right over here. Let me look at my book for a second. 1, 2, 3. 2, 3. I'm going to be on 3. 1, 2, 3. Okay, so point B was 2 units left. It will be now 2 units above x. It was 3 units above x. It's now going to be 3 units right of y. So 1, 2, 3 units right of, 3 units right of y and 2 units above x. So this is going to be your new B prime. This is still going to be A is going to stay where it is because you're rotating it about the axis. So that's still going to become A prime. That's going to stay the same. And C, let's see what C is, 2 units to the right of Y. So it's now going to be 2 units below X. And it's going to be, it's currently 3 units above X. It's going to be 3 units to the right of Y. 1, 2, 3. Wait, 1, 2. Yeah, so 1, 2, 3. Going to be a 3, -2. 1, 2, 3, -2. Yep, in the right spot there. So that will be our rotation. Let's connect our dots here. There it is. That's our rotation of 90 degrees clockwise for our triangle. So if we were to apply our rules for 90 degrees clockwise, Just going to write the rules here. So x and y, you're going to memorize these rules, is going to become y comma negative x. So let's just take the coordinate of b. This was originally negative 2, 1, 2, 3. This was negative 2 comma 3 originally. So now b was negative 2 comma 3. And now b prime is going to switch places. 3 is going to become the first one, and the x is going to become the second, and it's going to change to the opposite sign. So it was negative, now it's going to be positive. So let's see if that worked out. Do we end up with 1, 2, 3, and 2 up? We sure did. So that rule will always work. That's the best thing to do, is to memorize, and you know you won't be making mistakes. Let's just do C. A stayed the same, obviously, because 0, 0 switched to still 0, 0. C was, let's see, it was positive 2, comma, 1, 2, 3 up. Now, the new C, so it was 2, comma, 3. C prime is going to switch places. 3 is going to be in front. 2 is going to be behind, and it's going to change to the opposite sign, so negative 2. So let's see if that worked. So it should be positive 3 and negative 2. Yes, it is. This turned out to be 3, negative 2. That makes rotations a lot easier if you have those memorized. Okay, I believe I want to show you another one. Okay. So we're going to rotate quadrilateral A, B, C, D, 100, oops, can't see this, 180 degrees around the origin. Here it is. And do I have a different pen here? I want to just put the coordinates, which are already written up here for you, but let's just put them. 1, 2, A is at 0, 0, obviously. C is at 4, 2, and D is at 3, 0. Okay, those are the coordinates. And remember, rotating 180 degrees, the coordinates don't switch places, they just change to the opposite sign. So we're taking this and we're moving it like that, okay? So if I do that, I will get the new coordinates. A prime is going to still be at 0, 0. B, the coordinates don't switch places, they just change signs. So B is going to be negative 1, negative 2. Let's put that in there. B prime, negative 1, negative 2. C, which is 4, 2, is now going to become negative 4, negative 2. 1, 2, 3, 4, 1, 2, negative 4, negative 2. And then D was 3, 0. It's going to change to the opposite sign to negative 3, 1, 2, 3, and then stay on 0. And that will be D. And then if I connect, and then don't forget A prime stays the same, A prime. And I would connect my dots. Here we are, that's 180 degree rotation. And note that I don't have to say if it's clockwise or counterclockwise, because if I go 180 degrees this way, it's going to give me the same thing as 180 degrees that way. Okay, let's take a look at one more. We're going to go a rotation of 270 degrees clockwise. Right here, 270 degrees clockwise around the origin. Now, notice how the rule for clockwise is the same as 90 degrees counterclockwise. Okay, and I highlighted that here. Same as a 90-degree rotation counterclockwise. So let's just put the coordinates here. We have 0, 0, 0, 0. B is at 1, 2. C is at 4, 2. And D is at 3, 0, just like it was before. But now 270 degrees, and this isn't the same shape, but it'll kind of give you the general idea. 270 degrees clockwise is going to go 1/4 turn, 2/4 turn, 3/4 turn. And that's the same as 90 degrees counterclockwise. Boom. You see how that works? This is 3/4. 1, 2, 3. If I was to go this way, 1. It's going to be the same spot. So I'm just going to memorize the rules for 90 degrees counterclockwise. So 90 degrees counterclockwise, they switch places and the first value becomes the opposite sign. So A prime is going to switch, the zeros can switch and they're not going to be any different sign because 0 has no sign. So A prime is going to stay in the same spot. Well, actually double prime we'll call it because we're switching. Okay, and B was 1, 2. We're going to switch them to 2, 1, and then we're going to change the sign of the first one. It's going to become -2. So -2, 1, that's going to be B prime, double prime, -2, 1. C was 4, 2. They're going to switch places, and the first one's going to become the opposite sign. So C is going to be -2, up 4. 1, 2, 3, 4. That's going to become C double prime. And then D was 3, 0. It is now going to be 0, 3. 1, 2, 3. Okay, and then I connect my dots. Hopefully you can see that okay. Zoom in on it if you want. There we are. That is a rotation of 270 degrees clockwise or 90 degrees counterclockwise. Notice how this edge that was on the x-axis is now on the y-axis. Okay. Okay, we just did our graphing under the dot camera. Let's talk about multiple rotations. Now notice in real life, you could have a translation, you could have a translation and a rotation, you could have a translation, a rotation, and a reflection. You can have all kinds of different things. Let's just talk about a couple of rotations. So find the coordinates of point C, which is at 4, 2, after a 90 degrees counterclockwise rotation, followed by a 180 degree rotation. So I think the thing will come up, but I just want to show it to you this way first. So it's currently at 4, 2. We want to go 90 degrees counterclockwise. So what that's going to do, so this is the counterclockwise rule, XY is going to change places, and the first value is going to be negative, or the opposite of what it was. If it was negative, it becomes positive. So we're going to switch places, 2, and then 4, and the first value is going to become negative. Now we have to do a 180 degree rotation. The rule for a 180, X and Y don't switch places, they just switch signs. So they become the opposite of what they were. Okay, so they're now -2 is going to become the opposite of that, +2, and +4 is going to become the opposite of that, -4. That is a rotation, 90 degrees counterclockwise, followed by a 180 degree rotation. Okay, let me just bring that up, and I'm sure it will pop up for us. Okay, the new coordinate would be -2, 4, and then the second turn would become 2, -4. So that's our answer. Okay, it's your turn to try some of these harder ones. See you back in a moment. Okay, welcome back. We're going to talk about a little higher order thinking. So Lucas is playing a game where he has to rotate a figure for it to fit in an open space. Every time he clicks a button, the figure rotates 90 degrees clockwise. Okay, kind of going toward the right, right? How many times does he need to click the button so that each figure returns to its original orientation? Here's figure A. He wants it to go to the right, and he wants to know how many clicks until he gets it back to looking like it does right now. Well, let's test it. There's click 1, and there's click 2. So how many times did it take him to get it back to where it started? 2 times. Okay, let's look at a different figure. How many times does he have to click it to get it back to where he started? 1 time, right? It doesn't matter. You turn it once and it's back to where it was. It looks the same. It's a square. Squares only have to be turned once. And then this figure here. How many clicks will I need to get it back to where it is right now? Let's test it. 1, 2, 3, 4. So it took 4 times to get it back to where it needed to be. Okay. Triangle ABC is reflected across the y-axis to form the image A prime, B prime, C prime, reflected across the vertical axis, y. Triangle A prime, B prime, C prime is then reflected across the x-axis to form the image A double prime, B double prime, C double prime. What type of rotation can be used to describe the relationship between A double prime, B double prime, C double prime, and triangle ABC? Well, let's visualize it for just a moment. Let's make a coordinate graph here, a simple one. And triangle ABC is going to be, let's just say it's right here. If it's reflected across the y-axis, it's going to be reflected to over here, correct? And then if it's reflected again over the x-axis, it's going to end up over here. What type of rotation would be the same result? Well, you're going to be turning it and turning it again. So it would be a rotation of 270 degrees counterclockwise. If triangle ABC is 180 degree, triangle A prime, double prime, B prime is a 180 degree rotation. Oh, 180, I was wrong, 180. Okay. Not 270, 180. Okay. Point A is on the y-axis. Describe all possible locations of image A prime for rotations of 90 degrees, 180 degrees, and 270 degrees. Include the origin as a possible location for A. So let's see if I can draw this. I always have to erase it because I got to bring the words up. So if A is here, and you rotated it 90 degrees, A would still be there, wouldn't it? If I rotated it to 180 degrees, A point would still be there. If I rotated it 270 degrees, the A point would still be there if it's at the origin. What if I move it to up here? What's going to happen if I rotate it 90 degrees? Well, let's take a look. If A is on the origin, we just talked about, then A prime for any rotation will stay on the origin. If A is on any other spot on the y-axis, which is where we just are right now, then the rotation of 90 or 270 will put A prime on the x-axis. Think about it. When we rotate it 90 degrees, it'll be here. If we rotate it another 90 degrees, that's 270, it'll be over here, right? It will be on the X, 270. No, it would be over here. Sorry. Let me erase that. Okay. Why? Because We started here. That's one turn. We need to go 3 turns for 270. 2 turns, 3 turns. So either place, it's going to end up on the x-axis. Make sense? Hopefully. And then if A is on any other spot on the y-axis, then a rotation of 180 degrees is going to leave it on the y-axis, right? So let's do a different color. So if it was here, and we go 180 degrees, that's 2 spots. There's 1/4, and that's 2/4. So it would end up right there, back on the y-axis again. Okay, you gotta try to visualize some of this, okay? All right. So your homework will be on Google Classroom, and I will see you later. Bye.